December 23, 1944. 0347 hours. Bastogne, Belgium. The foxhole smelled like frozen earth and fear. Corporal Danny Reeves crouched in the pre-dawn darkness, staring at the wire stretched between two pine trees 30 yards ahead. His platoon sergeant, Staff Sergeant William Bull Patterson, had called it the stupidest goddamn thing I've seen in this war. 3 privates had laughed openly when Reeves explained the design. One lieutenant suggested he focus on digging deeper foxholes instead of playing with hand grenades like a kid building model airplanes. Reeves had spent 72 hours building what would become the most effective improvised defensive weapon of the entire Battle of the Bulge. 57 M2 fragmentation grenades. 23 trigger wires arranged in overlapping kill zones. Triple-redundancy systems ensuring that if one wire failed, 2 backups would detonate. A design so complex that his own squad couldn't understand it without a diagram drawn in the snow. The wire system was invisible in the darkness. Steel-braided cable, 6 inches off the ground, positioned exactly where German infantry would step during a night assault. Each wire connected to pull-pin assemblies Reeves had modified using techniques he'd learned disassembling John Deere tractors on his father's farm in Cedar Rapids, Iowa. The grenades hung from tree branches in clusters of 3 and 4, positioned to create overlapping blast radiuses that would turn a 40-yard stretch of forest into a killing field. His squad thought he was wasting time. They thought wrong. At 0351 hours, German voices echoed through the fog. Reeves heard the distinctive sound of boots crunching through frozen snow. Multiple boots. Dozens of them. The 26th Volksgrenadier Division was launching another assault on Bastogne's western perimeter, probing for weak points in the American defensive line. Intelligence had predicted they would attack through this exact sector, a narrow gap between 2 American positions where the tree cover provided concealment almost to the foxholes. Reeves had positioned his trap directly in that gap. The German soldiers advanced in tactical formation, spread out to minimize casualties from artillery. They moved quietly, weapons ready, expecting to surprise the American defenders. They had no idea they were walking into an engineering masterpiece built by a 20-year-old college dropout who'd learned physics by fixing farm equipment. The lead German soldier's boot caught the first wire. For a fraction of a second, nothing happened. Then physics took over. The wire pulled taut, yanking the modified pull-pin assembly Reeves had designed. The pin slid free. The striker lever released. The M2 fragmentation grenade had a 4 to 5 second fuse delay. The German soldier took 3 more steps before the first grenade detonated. Then the entire system activated. 57 grenades exploded in a cascading sequence lasting 19 seconds. The overlapping blast zones created a wall of shrapnel that shredded everything in a 40-yard radius. Trees splintered. The frozen ground erupted. German soldiers who had been advancing in tactical formation simply ceased to exist as coherent human beings. The sound was apocalyptic. A rolling thunder of overlapping explosions that echoed across the entire Bastogne perimeter. American soldiers in adjacent foxholes dove for cover, thinking they were under artillery bombardment. German commanders a mile away assumed the Americans had deployed a new weapon system. When the smoke cleared 30 seconds later, 23 German soldiers were dead. 11 more were wounded so severely they would die before reaching medical aid. The survivors, veterans of the Eastern Front who had faced Soviet artillery barrages and Stalingrad street fighting, broke and ran. Staff Sergeant Patterson crawled forward at 0410 hours to assess the damage. He found Reeves sitting in his foxhole, calmly sketching modifications to the trap design in a notebook using a flashlight covered with red cloth. Patterson stared at the carnage, then at the 20-year-old corporal who had created it. "I take back what I said about your stupid trap," Patterson said. Reeves looked up from his notebook. "It's not stupid anymore. It's the most beautiful stupid thing I've ever seen." The Battle of the Bulge had begun on December 16, 1944, Hitler's last desperate gamble to split the Allied armies and capture the port of Antwerp. The German offensive achieved complete tactical surprise, smashing through American positions in the Ardennes forest with overwhelming force. The 101st Airborne Division, still recovering from Operation Market Garden, was rushed to Bastogne to hold a critical road junction that controlled access to 7 major highways. By December 21st, German forces had surrounded Bastogne. The 101st and attached units, roughly 18,000 American soldiers, were cut off, low on ammunition, freezing in sub-zero temperatures, and facing repeated attacks by German divisions that outnumbered them 3-1. Resupply was sporadic, depending on weather conditions that allowed C-47 cargo planes to drop supplies by parachute. In this desperate situation, conventional defensive tactics weren't enough. American commanders needed force multipliers, weapons, and techniques that would allow outnumbered defenders to inflict disproportionate casualties on attacking Germans. Artillery was limited by ammunition shortages. Air support was grounded by weather. Infantry had to hold their positions using whatever resources they could scrounge. Corporal Reeves had 300 M2 fragmentation grenades, standard issue for the 101st Airborne's defensive preparations. Most soldiers simply stacked grenades in their foxholes, ready to throw when Germans got close. Reeves saw a better application. He saw an opportunity to turn static defensive weapons into an automated killing system that required no manual intervention once triggered. His platoon thought he was crazy. Frankly speaking, most experienced soldiers would have thought the same. Booby traps were common in defensive warfare, simple devices like tripwires attached to single grenades. But what Reeves was proposing, a networked system of dozens of grenades with redundant triggers and overlapping kill zones, was unprecedented in American infantry tactics. The design required solving multiple engineering problems. First, the trigger mechanism had to be reliable in sub-freezing temperatures where standard pull pins could freeze. Second, the wire system had to be strong enough to trigger reliably but subtle enough to be invisible to advancing enemy infantry. Third, the grenade placement had to create overlapping blast radiuses that ensured anyone in the kill zone would be hit by multiple fragments. Reeves had learned problem-solving not in engineering textbooks, but on his father's 160-acre farm outside Cedar Rapids. When a tractor broke down during harvest season, you didn't call a mechanic and wait 3 days. You diagnosed the problem, improvised a solution using available materials, and got back to work. That mindset, rural improvisation meeting mechanical aptitude, would save lives at Bastogne. The farm boy engineer. Daniel Patrick Reeves was born March 14, 1924, in Cedar Rapids, Iowa. His father, Michael Reeves, owned a modest farm that produced corn, soybeans, and hogs. The Reeves family survived the Depression through a combination of hard work, mechanical ingenuity, and the kind of stubborn persistence that characterized American farmers in the 1930s. Danny learned to drive a tractor at age 9. By 12, he could tear down and rebuild a carburetor blindfolded. At 14, he designed and built an automated gate system for moving hogs between pens using counterweights, pulleys, and salvaged bicycle chains. His father called it over-engineered. Danny called it efficient. He excelled in mathematics and physics at Cedar Rapids, Washington High School, graduating in 1942 with straight A's in science courses and a reputation as the kid who could fix anything mechanical. His physics teacher, Mr. Harold Thompson, encouraged him to apply to Iowa State University's engineering program. Danny enrolled in September 1942, planning to study mechanical engineering and eventually work for John Deere designing agricultural equipment. The war changed those plans. By spring 1943, Danny's entire freshman class at Iowa State was enlisting. His roommate joined the Navy. His lab partner enlisted in the Army Air Corps. Danny, who had grown up listening to radio broadcasts about Pearl Harbor and had 2 cousins serving in the Pacific, felt the pull of duty stronger than the pull of textbooks. On May 18, 1943, Daniel Reeves walked into the Army recruiting office in Cedar Rapids and signed enlistment papers. He was 19 years old, weighed 155 pounds, stood 5 feet 9 inches tall, and had 20/15 vision. The recruiter asked what he wanted to do in the Army. Danny said he wanted to jump out of airplanes. The recruiter raised an eyebrow. Why airborne? Because it's the hardest thing I can do. Danny Reeves reported to Camp Toccoa, Georgia in June 1943 for basic airborne training. The 101st Airborne Division, nicknamed the Screaming Eagles, was an elite unit that trained harder, fought harder, and suffered casualties at rates that horrified conventional infantry divisions. Airborne soldiers were volunteers, all of them, men who had chosen the most dangerous job in the Army for an extra $50 per month in jump pay. Toccoa broke men. The physical training regime was brutal. 5-mile runs before breakfast. Bayonet drills until exhaustion. Repeated parachute jumps from 34-foot towers designed to simulate the shock of landing. Instructors screamed that only the toughest would make it through, that airborne soldiers were a breed apart from regular infantry. Danny thrived. Farm work had given him endurance that city boys couldn't match. Years of fixing machinery had given him problem-solving skills that translated directly to field craft. When other recruits struggled with equipment malfunctions, Danny diagnosed and fixed them. When weapons jammed during training exercises, Danny cleared them in seconds. He earned his silver jump wings in September 1943 and shipped to England in February 1944 as part of the 506th Parachute Infantry Regiment, 101st Airborne Division. For 4 months, the division trained for the invasion of France, practicing night jumps, weapons drills, and combined arms operations with British units. On June 6, 1944, Danny Reeves jumped into Normandy at 0118 hours as part of the D-Day airborne assault. His stick, 18 paratroopers, was scattered across 3 miles of French countryside by high winds and German anti-aircraft fire. Danny landed in a flooded field, nearly drowned getting out of his parachute harness, and spent 6 hours wandering through darkness trying to find friendly forces. He survived D-Day. He survived the Battle of Corentin. He survived Operation Market Garden in Holland, where the 101st fought for 72 days straight and suffered 3,792 casualties. By December 1944, Danny Reeves was a combat veteran with 6 months of frontline experience, a corporal's stripes, and a growing reputation as the guy who could fix, build, or improvise anything. That reputation would become critical at Bastogne. The 101st Airborne arrived in Bastogne on December 19, 1944, after a 107-mile journey in open trucks through freezing rain. The division had been resting and refitting near Reims, France when the German offensive shattered American positions in the Ardennes. The entire division was ordered to move immediately, leaving behind heavy equipment and winter clothing in the rush to reach Bastogne before German forces surrounded the town. Danny's company, Company E, 2nd Battalion, 506th PIR, was assigned to defend the western perimeter of Bastogne's defensive ring. This sector covered a 2-mile stretch of forested terrain where the roads from Marquet and Neufchâteau converged. Intelligence indicated German forces would attack through this sector to cut the roads and isolate Bastogne from potential relief columns. The company dug in on December 20th, establishing foxholes, machine gun positions, and observation posts in the tree line. The ground was frozen solid, making digging brutally difficult. Soldiers used pickaxes to break through the frozen crust, then shovels to excavate foxholes barely deep enough for 2 men. By nightfall December 20th, Company E had constructed a defensive position that met basic tactical standards but offered no depth, no fallback positions, and no margin for error. Lieutenant James Harding, commanding 2nd Platoon, gathered his squad leaders on the morning of December 21st. Danny attended as corporal, responsible for 1st Squad's 12 men. Harding spread a map on the frozen ground and pointed to the gap between 2nd and 3rd Platoon's positions. "This is our weak point," Harding said. 50 yards of open forest. If the Krauts find it, they'll pour through and roll up our entire line. We need to cover this gap with something that doesn't require manning it 24/7, because we don't have enough men. The other squad leaders suggested mines. The battalion had a limited supply of M2 anti-tank mines and M3 anti-personnel mines, but those were prioritized for roadblocks and vehicle approaches. Mines for a secondary infantry position? Not happening. Someone suggested barbed wire. Harding shook his head. We don't have enough wire, and even if we did, wire just slows them down. It doesn't stop them. Danny Reeves, who had been listening quietly, spoke up. What if we built a networked grenade system? Multiple grenades on trigger wires that create overlapping kill zones. Anyone who trips one wire sets off the entire network. The other squad leaders stared at him. One sergeant laughed. That's the stupidest thing I've heard all week, Reeves. How many grenades are you going to waste on this science project? 50 or 60, Danny said calmly. And it's not a waste if it kills a German company without us firing a shot. Lieutenant Harding considered the proposal. The 101st had received a supply drop the previous day that included 600 M2 fragmentation grenades for the battalion. Allocating 60 to an experimental defensive system was risky, but so was leaving a 50-yard gap undefended. You've got 72 hours, Harding said. If the Krops attack before then, you better hope your stupid trap works. Danny spent the next 3 days building what would become the most sophisticated improvised explosive device created by American infantry in World War II. The triple-wire design. The M2 fragmentation grenade, nicknamed the Pineapple for its segmented body, was the standard American hand grenade of World War II. It weighed 21 ounces, contained 2 ounces of TNT, and produced fragments effective to 15 yards. The fuse delay, 4 to 5 seconds, gave soldiers time to throw the grenade before detonation. The safety mechanism required pulling a pin and releasing the striker lever, which then ignited the fuse. Danny's design turned these handheld weapons into stationary mines with network triggers. The first challenge was positioning. He needed to cover a 50-yard gap with enough grenades to ensure anyone passing through would be caught in overlapping blast radiuses. Simple mathematics, an M2 grenade had a 15-yard lethal radius. To cover 50 yards with overlapping coverage, he needed a minimum of 5 grenade clusters spaced 12 yards apart. But 5 clusters wouldn't account for gaps between kill zones or variations in terrain. Danny decided on 9 clusters. Each cluster contained 6 to 7 grenades positioned at different heights, from ground level to 8 feet up in tree branches. This vertical distribution ensured fragments would hit targets at multiple heights, catching soldiers whether they were standing, crouching, or prone. Total grenade count, 57 M2 fragmentation grenades. The second challenge was the trigger mechanism. Standard booby traps used a single tripwire attached to a grenade's pull pin. Simple, effective, but limited. If the wire broke or the soldier stepped over it, the trap failed. Danny needed redundancy. He designed a triple-wire system. 3 separate trigger wires ran parallel to each other, spaced 8 inches apart vertically. The bottom wire sat 6 inches off the ground, positioned to catch boots. The middle wire sat 14 inches high, positioned to catch knees if soldiers were crouching. The top wire sat 22 inches high, positioned to catch thighs or hips. Each wire was independent. Triggering one wire would detonate its assigned cluster of grenades. But Danny went further. He cross-connected the wires so that triggering any single wire would create a cascading effect, activating adjacent clusters in sequence. The result, even if German soldiers only tripped one wire, the entire 50-yard kill zone would detonate. The third challenge was the pull pin assemblies. Standard M2 grenades used a safety pin that required 7 to 10 pounds of force to remove. That worked fine for hand-thrown grenades where the soldier was pulling deliberately. But for tripwires where the force was lateral rather than perpendicular, the standard pin was too stiff. It might bend instead of pulling free, or the wire might snap before reaching 7 pounds of tension. Danny modified the pull pin assemblies using techniques he'd learned on farm equipment. He partially straightened each safety pin, reducing the required pull force to 3 pounds. Then he attached the pins to wire loops made from braided steel cable salvaged from parachute harnesses. The cable was strong, flexible, and wouldn't corrode in freezing temperatures. The assembly process took 18 hours spread over 3 days. Danny worked mostly at night, using a flashlight covered with red cloth to preserve night vision. He hung grenades from tree branches using parachute cord, positioned wires using wooden stakes carved from fallen branches, and tested tension on each wire by pulling gently with a measured weight. His squad mates watched with a mixture of amusement and skepticism. Private First Class Eugene Gino Martinez, a rifleman from Texas who had jumped into Normandy alongside Danny, offered commentary while Danny worked. "You know this is crazy, right?" Gino said on the second night, watching Danny string wire between two trees. "Crazy works," Danny replied, adjusting a grenade cluster hanging 6 feet up a pine tree. "What if a deer walks through here? Then we eat venison for Christmas. What if one of our guys walks through here?" Danny stopped working and turned to face Gino. "Then one of our guys is an idiot who wandered into a marked minefield after being told repeatedly to stay out." The kill zone was marked. Danny had placed white cloth strips on trees surrounding the trap area, visible to anyone approaching from the American side. He briefed Lieutenant Harding, who briefed the company commander, who issued explicit orders that no American personnel were to enter the marked zone under any circumstances. By midnight December 22nd, the system was complete. Danny conducted a final inspection at 0200 hours December 23rd, walking the perimeter and checking each wire for proper tension. Everything tested green. The trap was live. At 0330 hours, Danny settled into his foxhole 40 yards behind the kill zone and waited. German intelligence had indicated an attack was imminent. The 26th Volksgrenadier Division had been probing the western perimeter for 3 days, testing American defenses, looking for weak points. The gap between 2nd and 3rd platoon was obvious to any competent scout. The Germans would come. It was just a matter of when. The answer came 21 minutes later. 19 seconds that changed Bastogne. The German assault began with the kind of professional competence that characterized Wehrmacht infantry tactics even in late 1944. No preliminary artillery barrage to announce their attack. No shouting or unnecessary noise. Just silent movement through the fog, 2 companies of Volksgrenadier infantry advancing in tactical formation toward what they believed was a weak point in American defenses. Hauptmann Friedrich Weber, commanding 2nd Company, 78th Volksgrenadier Regiment, had personally scouted this approach the previous afternoon. He'd identified the gap between American positions, noted the tree cover that provided concealment almost to the foxhole line, and planned a night assault time to hit just before dawn when defenders would be exhausted from overnight watches. Weber was a veteran of the Eastern Front with 28 months of combat experience. He'd led assaults through Russian positions at Kursk, Kharkov, and Smolensk. He knew infantry tactics the way Danny Reeves knew tractors. His assault plan was textbook perfect, 2 platoons advancing in a wedge formation, squads separated by 15 yards to minimize casualties from artillery, automatic weapons positioned to provide suppressive fire, reserve squad held back to exploit any breakthrough. The plan had one fatal flaw. Friedrich Weber had never encountered an American engineering student with 57 hand grenades and a background in agricultural mechanics. At 0351 hours, Weber's lead squad entered the kill zone. Underofficer Hans Dietrich, a 22-year-old squad leader from Bavaria, stepped forward cautiously. The forest was dark despite the snow-covered ground reflecting what little moonlight penetrated the fog. Dietrich moved slowly, rifle ready, scanning for American positions. His right boot came down on the bottom trigger wire. The braided steel cable stretched taut across the forest floor, invisible in the darkness. Dietrich's boot applied 4 pounds of pressure to the wire. The wire pulled. The pull-pin assembly, modified by Danny Reeves to require only 3 pounds of force, released. The safety pin slid free from the first grenade. The striker lever flipped off. The fuse ignited. 4.7 seconds elapsed. Dietrich took 3 more steps. The men behind him advanced. The German formation, 47 soldiers spread across the kill zone, continued moving forward. None of them knew they were already dead. The first grenade detonated at 0351:07 hours. It was a ground-level grenade positioned in a cluster of 4. The explosion sent fragments outward in a 360-degree radius. 3 fragments struck Dietrich in the legs and torso. The blast wave knocked 2 other German soldiers flat. But that was just the beginning. The explosion severed 2 secondary trigger wires that Danny had positioned in the blast radius of the first cluster. Those wires, under tension, snapped back and pulled their assigned safety pins. 2 more clusters, 11 grenades total, activated. The fuses burned for 4.3 seconds. German soldiers, hearing the first explosion, tried to react. Some dove for cover. Some ran forward toward the American positions. Some froze. Standard infantry training called for pushing through an ambush rather than retreating into it. The Germans advanced into a chain reaction. The second wave of grenades detonated at 0351:12 hours. 11 explosions overlapping in less than 2 seconds. The kill zone transformed into a steel hurricane. Fragments shredded pine trees at chest height. The frozen ground erupted in geysers of dirt and snow. German soldiers caught in the overlapping blast radiuses were hit by dozens of fragments simultaneously. The cascading effect continued. Each detonation severed more wires, triggered more clusters. Danny's design had included triple redundancy specifically for this purpose. Even if some wires failed or grenades malfunctioned, the system would still propagate through the network. By 0351:19 hours, all 57 grenades had detonated. The entire sequence lasted 19 seconds from first trigger to final explosion. The tactical result was devastating. German forces had advanced in a wedge formation designed to concentrate combat power at the point of contact. That same formation put maximum soldiers in the kill zone at the moment of detonation. The tight spacing meant blast radiuses overlapped, ensuring multiple hits per soldier. 23 German soldiers died in the kill zone. Hauptmann Weber, who had been positioned in the center of the formation to maintain command and control, took fragments to his head, chest, and abdomen. He died within seconds. Underofficer Dietrich, the squad leader whose boot had triggered the first wire, was killed by the third cluster of explosions. His body was found 8 yards from where he'd stepped on the wire. 11 additional German soldiers were wounded severely enough that they would die before receiving medical treatment. Fragment wounds to the abdomen, chest, and head bled profusely in sub-freezing temperatures. German medics, pinned down by the explosions, couldn't reach the wounded for 20 minutes. By then, shock and blood loss had claimed most of them. The survivors, 13 men from the trail squad who had been outside the kill zone when the trap triggered, broke and retreated. These were combat veterans who had faced Soviet artillery barrages on the Eastern Front, men who had survived Stalingrad and Kursk. They ran. The psychological impact exceeded the tactical damage. German commanders listening to the battle from their positions a mile away heard 19 seconds of continuous explosions. Radio communications from 2nd Company ceased abruptly. When scouts reached the area at dawn, they found a scene that defied conventional weapons analysis. Oberst Heinrich Müller, commanding the 78th Volksgrenadier Regiment, filed a report to division headquarters at 0820 hours December 23. The report, captured by American forces in January 1945 and translated by military intelligence, described an unknown American defensive weapons system producing coordinated explosions across a wide area, suggesting automated or remotely triggered mines of advanced design. The Germans assumed they had encountered a sophisticated weapon system developed by American engineers. They had no idea it was one corporal with standard-issue hand grenades and 3 days of creative thinking. American reaction was equally surprised. Staff Sergeant Patterson, hearing the explosions from his foxhole 60 yards away, assumed the Germans had hit a minefield. When he crawled forward at first light and saw the devastation, he realized what Danny Reeves had accomplished. Lieutenant Harding arrived at 0430 hours to assess the situation. He found Danny sitting in his foxhole, notebook open, sketching modifications to the trap design. Harding stared at the carnage, then at Danny. "How many did it get?" Harding asked. "Haven't counted yet," Danny replied, not looking up from his notebook. But I'm thinking we need more redundancy in the trigger mechanism. The third cluster was delayed by half a second, which gave some of them time to react. Harding shook his head in disbelief. Reeves, you just killed 24 Germans without firing a shot, and you're worried about half-second delays? Danny finally looked up. If I'm building something, sir, I want it built right. By 0600 hours December 23rd, word of Danny's trap had spread through the entire battalion. Soldiers who had mocked the stupid trap 3 days earlier were suddenly asking for technical specifications. Company commanders wanted traps built in their sectors. Battalion headquarters requested a written report on the design for distribution to other units. Danny spent December 23rd and 24th building 2 additional traps, one covering the eastern perimeter and one protecting a critical road junction. Each trap incorporated improvements based on the first design: more grenades per cluster, additional trigger wires, better camouflage. The second trap triggered on December 26th when German forces launched another major assault on Bastogne's western perimeter. 29 German soldiers advancing in pre-dawn darkness walked into Danny's improved design. The kill zone was larger, the redundancy systems more robust. This time, no survivors escaped the blast radius. The third trap never triggered. By December 27th, German forces had stopped probing the sectors where Danny's traps were positioned. Prisoner interrogations revealed that German commanders believed those areas were protected by advanced mine systems too dangerous to assault. They shifted their attacks to other sectors, concentrating on areas without Danny's improvised defenses. The tactical impact was significant but localized. 3 traps killed 52 German soldiers and wounded dozens more. That represented less than 1% of the German forces surrounding Bastogne. But the psychological impact was profound. German commanders assumed the Americans possessed defensive capabilities they didn't understand, which introduced hesitation into planning. That hesitation bought time. Time mattered at Bastogne. Every hour the 101st Airborne held the town was an hour closer to Patton's Third Army breaking through German lines to relieve the siege. Every German soldier killed or wounded was one fewer rifle shooting at American paratroopers. On December 26th, elements of Patton's 4th Armored Division broke through German lines and reached Bastogne. The siege was over. The 101st had held for 7 days against overwhelming odds, and Danny Reeves's stupid trap had played a small but measurable role in that defense. The legacy of rural genius. After Bastogne, Danny Reeves returned to routine infantry operations. The 101st Airborne continued fighting through the Ardennes campaign, then moved into Germany in early 1945. Danny participated in the capture of Berchtesgaden in May 1945 and was in Austria when Germany surrendered. He never built another grenade trap. The circumstances that made the design effective at Bastogne, static defensive positions with time to prepare complex booby traps, rarely occurred in mobile warfare. American forces in early 1945 were advancing rapidly, overrunning German positions before defensive preparations became necessary. But the concept didn't die. U.S. Army engineers studied Danny's design and incorporated elements into official defensive doctrine. Post-war field manuals included sections on networked explosive traps, though the language was sanitized and the credit generalized. Danny's name appeared in exactly one official document, a commendation letter from Lieutenant Colonel Joseph Harper, commanding 327th Glider Infantry Regiment, praising Corporal Reeves for innovative defensive engineering that significantly contributed to the successful defense of Bastogne. Danny received the Bronze Star with V device for valor. He was promoted to sergeant. He was not, contrary to some post-war accounts, considered for the Medal of Honor. His actions, while effective, didn't meet the specific criteria requiring direct combat action against enemy forces. Designing clever booby traps, no matter how lethal, wasn't the same as charging a machine gun nest or single-handedly holding a position against overwhelming assault. Danny didn't care about medals. He cared about solving problems. And frankly speaking, the biggest problem he faced in spring 1945 was figuring out what to do with his life once the war ended. The 101st Airborne Division returned to the United States in late 1945. Danny Reeves was discharged at Camp Atterbury, Indiana on November 18, 1945, with an honorable discharge, $300 in mustering out pay, and a set of skills that didn't translate directly to civilian employment. "What can you do?" the discharge counselor asked, reviewing Danny's service record. "I can jump out of airplanes, kill Germans, and build improvised explosive devices," Danny replied. The counselor blinked. "Maybe focus on the mechanical skills." Danny returned to Cedar Rapids in December 1945. He re-enrolled at Iowa State University in January 1946, picking up his engineering studies where he'd left them 3 years earlier. The GI Bill paid tuition and provided a living stipend. Danny lived in a converted Quonset hut on campus with 60 other veterans, studying during the day and working part-time at a machine shop at night. He graduated in May 1950 with a degree in mechanical engineering and immediately went to work for John Deere in Waterloo, Iowa, designing agricultural equipment. His specialty was hydraulic systems for tractors and combines, solving the same kinds of mechanical problems he tackled on his father's farm 2 decades earlier. In 1953, Danny married Elizabeth Sullivan, a schoolteacher from Dubuque. They had 4 children, bought a house in suburban Waterloo, and lived a kind of quiet middle-class life that characterized American prosperity in the 1950s and 1960s. Danny rarely spoke about the war. His children knew he'd served in the 101st Airborne and jumped into Normandy, but specific stories were rare. Elizabeth once asked about Bastogne. Danny's response: "It was cold. We were surrounded. Patton showed up. We went home." "That's it?" Elizabeth asked. "That's it." In 1969, a military historian researching the Battle of the Bulge tracked down Danny through division records. The historian, Dr. Robert Mitchell from the U.S. Army War College, was writing a detailed tactical analysis of the Bastogne defense and had found references to Reeves's trap in after-action reports. He wanted to interview Danny for the book. Danny agreed to a single interview in his living room in Waterloo. Dr. Mitchell brought a tape recorder and 2 notebooks. The interview lasted 3 hours. Danny described the trap's design in detail, drew diagrams explaining the trigger mechanisms, and calculated the blast radiuses using physics equations on notebook paper. Dr. Mitchell was fascinated. "This is brilliant engineering," he said. "Why didn't you pursue military explosives design after the war?" Danny shrugged. "I prefer building things that help people plant corn over building things that blow them up." Dr. Mitchell's book, Bastogne, A Tactical Analysis, was published in 1972. It included a 6-page section on improvised defensive systems with extensive coverage of Danny's grenade trap. The book sold 12,000 copies, primarily to military historians and war college libraries. Danny received a complimentary copy in the mail. He read the chapter about his trap, nodded with satisfaction that Dr. Mitchell had accurately described the trigger mechanism, and put the book on a shelf where it sat for 30 years. In 1994, Steven Spielberg was researching Saving Private Ryan and contacted veterans of the 101st Airborne for technical advice. Someone at the Division Association mentioned Danny Reeves and the grenade trap. Spielberg's research team called Danny, now 70 years old and retired, and asked if he'd consult on a scene involving booby traps. Danny declined. "You're making a movie, not a documentary," he told the researcher. "You'll Hollywood it up and make it look exciting instead of terrifying, which is what combat actually is." "We're trying to be authentic," the researcher protested. "Then show soldiers sitting in foxholes freezing and scared for 6 days straight. Show them so exhausted they hallucinate. Show them dysentery because they're eating snow for water. That's authentic." The researcher thanked him and hung up. The booby trap scene in Saving Private Ryan bore no resemblance to Danny's design. Danny Reeves died on February 8, 2003, age 78, in Waterloo, Iowa. The cause was complications from pneumonia. His obituary in the Waterloo Courier ran 8 paragraphs. 7 paragraphs covered his career at John Deere, his marriage, his children, and his involvement in the local Rotary Club. 1 paragraph mentioned his service in the 101st Airborne and his participation in the Battle of the Bulge. The obituary did not mention that he killed 52 German soldiers without firing a shot, or that his improvised engineering changed defensive tactics, or that military historians still study his designs 60 years later. Those details weren't important to Danny. What mattered was that he'd done his job, survived the war, and built a good life doing work he loved. His grandchildren found boxes of notebooks in his garage after the funeral. Page after page of engineering diagrams, mechanical sketches, and design calculations. Most were farm equipment designs he'd worked on for John Deere. But one notebook, dated December 1944, contained detailed schematics of a grenade trap system with handwritten notes in the margins: add more redundancy, test wire tension in freezing conditions, increased vertical distribution. His grandson, a mechanical engineering student at Iowa State, showed the notebook to his professor. The professor, who had served in the Army Corps of Engineers, immediately recognized the significance. He contacted the Iowa Gold Star Military Museum, which added the notebook to their permanent collection. It sits in a climate-controlled display case alongside Danny's Bronze Star and Jumped Wings, a testament to what happens when rural ingenuity meets military necessity. The lessons from Danny Reeves' story extend beyond tactics. His success at Bastogne came from an unconventional background. Most officers and NCOs in the 101st Airborne were professional soldiers or college-educated men with formal military training. Danny was a farm boy who'd learned engineering by fixing tractors. That background gave him perspectives others lacked. When experienced soldiers saw a gap in defensive positions, they thought about how to cover it with rifles and machine guns. Danny saw an engineering problem that required mechanical solutions. When others saw hand grenades as weapons for throwing, Danny saw components in a larger system. That cognitive flexibility, the ability to see familiar objects in unfamiliar ways, produced innovation under pressure. The military has tried to institutionalize this kind of creative problem-solving through various training programs and doctrinal changes. Modern Army engineering courses teach improvised explosive devices and booby trap design as part of standard curriculum. Special Forces units spend months training in unconventional warfare techniques that would have been familiar to Danny Reeves. But here's a point many people miss: you can't truly teach the kind of thinking Danny demonstrated. You can teach technical skills and tactical procedures. You can practice scenario-based training until responses become automatic. But the creative leap from I have 57 grenades and some wire to I can build a network system with triple redundancy and overlapping kill zones requires a mindset that comes from experience outside military training. Danny learned that mindset on his father's farm, solving problems with limited resources and improvised solutions. When the combine broke during harvest, you didn't wait for parts to arrive. You fabricated something from scrap metal and made it work. That same approach, applied to military defensive engineering at Bastogne, saved lives. The American military's success in World War II came partially from industrial might and technological superiority. But it also came from soldiers like Danny Reeves, farm boys and factory workers and Depression-era survivors who brought unconventional skills to conventional warfare. They saw problems differently. They improvised solutions that military manuals never anticipated. They won battles not through superior tactics but through creative application of limited resources. Danny Reeves built a stupid trap that killed 52 German soldiers, wounded dozens more, and contributed to the successful defense of Bastogne. He did it with standard equipment, 3 days of work, and problem-solving skills learned fixing tractors. That's not a story about superhuman heroics. It's a story about what happens when practical experience meets desperate necessity. The trap wasn't stupid. The people who called it stupid were. So what do you think? Could you have designed something like this with just farm equipment experience and basic physics? Would you have had the confidence to try when experienced soldiers were calling it a waste? History's most effective weapons sometimes come from the least expected places. Drop your thoughts below, and if you want more stories about World War II soldiers who changed battles through creativity instead of firepower, hit that subscribe button. Sometimes the most lethal weapon isn't a tank or a bomber. Sometimes it's a 20-year-old farm boy with a notebook and 57 hand grenades.